This is the 2015 AIME1, and we're gonna go over it. Question 1. The expressions a equals to 1 times 2 plus 3 times 4 all the way plus 37 times 38 plus 39, and b equals to 1 plus 2 times 3 plus 4 times 5 all the way until 38 times 39. And then find the positive difference between integers a and b. Okay, so right off the bat, we can see that we can pair some of the numbers together to make the question easier. We pair 1 and 2, and it was 2 and 3. 3 and 4 was 4 and 5. And then all the way until 37 times 38 and 38 times 39. Notice how they all have a same factor. 2, 4, 38. And then if you want to have b minus a, we can factor these out when we get this. Now, what's left is a 30. Here we have a 39, and here we have a 1. So b minus a, we can get 1 minus 39. So now, notice these are 2's. They are all 2's. So we factor them out again. Look at this. Continuing, we can factor 2 out of here. We get 4 times 1 all the way to 19. Minus 38. What is 1 plus 9? What is 1 all the way plus to 19? It's this. So we get 4 times 190 minus 38. Which the answer is 722. Now on to question 2. The 9 delegates from the Economic Cooperation Conference include 2 officials from Mexico, 3 officials from Canada, and 4 officials from the United States. During the opening session, 3 of the delegates fell asleep. Assuming that 3 sleepers are determined randomly, the probability that 2 of the sleepers are from the same country is m over n. Find m plus n. So what we can do here is we figure out what is the equation. It's the denominator is of course going to be c minus 3, which gives us 84. What is the top? Top, we can include the principle of inclusion and exclusion, because we want only exact 2 sleepers from the same country, where if you count only 2 sleepers, you might count all 3 of them. So we gotta minus out the cases that all 3 of them are counted, which is not what we want. Okay, so first of all, we need to find all possible that 2 of the sleepers are from each country. So first of all, 2 sleepers are from Mexico. Mexicans, there's only 2 officials, so we only get 1 choice because it's like C22. We only get 1 choice. And then there's 7 choices for the other sleepers, which we get 7. Second, we get 2 from Canada. It's still quite simple. We get C3 2 times 7, which is 21. Now we got 2 from US. US has 4 delegates, so C4 2 times 7. We get 42. This is how all the possible ones. And then we need to minus out the 3 from each country. 3 from Mexico. We get 0 because there's only 2 delegates from Mexico. Now 3 from Canada. We get C3 3 times 3 equals 3. Now 3 from US. It's C4 3 times 3, which we get 12. Now we add the left side together and minus the right side over what we have 84 here, which the answer is 55 over 84. The answer is 139. On question 3, there's a prime number p such that 16p plus 1 is the cube of a positive integer. Find p. What we can do here is we can write out the cube, which is a to the power of 3. Now, one idea that seems quite doable is to move the 1 over, because you can actually factor it into a minus 1, a squared plus a plus 1, 16p. Now, it's 16 times a p. P, we know that's an odd number, because when you sub 2 in, that's 33, which is not a cube of positive integer. And then all the other primes are odd, so we get p is odd. And then 16p plus 1, we also know it's odd. It's equals to a cubed, so a is odd. A is odd, so a minus 1 is even. A squared plus a plus 1 is odd. So we can get a minus 1 is divisible by 16. We want the smallest a possible, so we try a equals to 17. A equals to 17, we get a to the power of 3 is this number. And then we get p equals to 307. 307, which is going to be a prime integer. So 307 is the answer. Question 4. Point B lies on the line segment AC, with AB equals to 16 and BC equals to 4. B, D, and E lie on the same side of AC, forming equilateral triangles. Let M be the midpoint of AE and be the midpoint of CD. The area of BM is x, find x squared. This problem isn't that hard. We can use analytic geometry. We set B as origin because everything is middle, so that will be the best if we set it to the origin. C is right here with C 4, 0. A is negative side with negative 16, 0. And D and E are somewhere here. We know that D's coordinate is going to be 8 root 3. Negative 8. Because this is 16. Well, I'm going to draw a triangle here. If this is a equilateral triangle, if this side is 16, then this is going to be 8. This is 60 degrees. We know that this is 8 root 3. So we know that D is negative 8 root 3. On the right side, the same. We get E is 2 root 3. Well, we have all the points coordinates. We can just easily bash it. We know that M is midpoint of AE. A is this, E is this. Midpoint. That's the middle of both coordinates. So we get M is negative 7 root 3. N is midpoint of these two. We get N is gonna be negative 2 4 root 3. Okay, next what we do is we just draw the triangle. B is here. M somewhere here. N is somewhere here. Here's the triangle. Now what do we do with this triangle? We make a square. Now we make a rectangle out of the outline of this triangle. We know the length of the square, 7. We know this, 4 root 3. We're just gonna find these areas, these triangle areas, which we also know because of the coordinates. And that's where B as the origin gets in hand, because this is 0, 0. Everything can be minus to 0, 0, which is way easier. Okay, we know this is gonna be 2. This is gonna be 5. This is gonna be 3 root 3. This is gonna be root 3. Now we just calculate it out. 15 root 3 plus 7 root 3 plus 8 root 3 divided by 2. And use this to minus it. And we get the answer is 13 root 3. Now 13 root 3 squared, we get 507, which is the answer. On this question, in the drawer, Sandy has 5 pairs of socks, each with a different color. On Monday, Sandy selects 2 individual socks at random from the 10 socks in the drawer. On Tuesday, Sandy selects 2 of the remaining 8, and Wednesday, select 2 from the remaining 6. The probability that Wednesday is the first day Sandy selects matching socks is m over n. Find m over n. Well, the order of how we select it doesn't matter, right? So we're gonna start from day 3. Okay, so on the fifth day, the probability that Sally choose the same sock on the 5th and 6th day is 1 over 9. Wait, just turn off. And then on the first day, the second day, the probability that first and second day are the same is this. How about the third and fourth day? We gotta do a bit of casework here. On the third day, if the so on Tuesday, if the sock matches the first sock, it's this, and then the second one it can be arbitrary, because both socks are selected. Any sock doesn't matter. Plus, if the sock color isn't the same as the first sock, then it's gonna be like this. That's the answer. We get 26 over 315. We add them, we get 351. No, 341. On this question, in the drawer, Sandy has 5 pairs of socks, each with a different color. On Monday, Sandy selects 2 individual socks at random from the 10 socks in the drawer. On Tuesday, Sandy selects 2 of the remaining 8, and Wednesday, select 2 from the remaining 6. The probability that Wednesday is the first day Sandy selects matching socks is m over n. Find m over n. Well, the order of how we select it doesn't matter, right? So we're gonna start from day 3. The probability that Sally choose the same sock on the 5th and 6th day is 1 over 9. Wait, just turn off. Probability that first and second day are the same is this. Okay, so on Tuesday, if the sock matches the first sock, it's this, and then the second one it can be arbitrary, because both socks are selected. Any sock doesn't matter. Plus, if the sock color isn't the same as the first sock, then it's gonna be like this. That's the answer. We get 26 over 315. We add them, we get 351. No, 341. For problem 6, A, B, C, D, E, and N are equally spaced on the minor arc of a circle. Points E, F, G, H, I, and A are equally spaced on the minor arc of the second circle with center E. Now, ABD exceeds AHG by 12 degrees. Find the degree measurement of BAG. Oh, we see that each of these are the same. Each of these and each of these are the same. So we assume one of these is going to be an X and one of these is going to be a Y. Some angles, like ECA, can have 2 different kinds of measurements, right? Because when, like, ECA is counted on circle C, it's going to be phi 1. And when ECA is counted on circle the center of the arc ABCDE is going to be O. So it's going to be like somewhere here, and it's going to be called O. Right? Now, angle ECA, if it's on circle O, is going to be like this, right? And it's going to be 360 degrees minus 4x divided by 2. It's equals to 180 minus 2x. Next, we can see angle ABD. ABD, we get 180 minus this on circle O. And it's 180 minus 2031 on circle C. So 180 from this, we get 180 minus 2 over 3, 3x over 2 equals to 180 minus 3y over 2 plus 12. When we solve this, we get x plus a equals to y. Sub this into this, because the two angles are the same. We get 5y equals to 180 minus 2x. We get x equals to 20, y equals 28 degrees, of course. Now we want the measurement of BAG. What is the angle BAG? We can divide it into BAE and EAG. And it's gonna be 3x plus 2 plus y equals to 58, which is the answer. For this question, we're given the square. E is midpoint of AD, connect CE, and then we're supposed to find two squares inside the trapezoid. We know the length, we know the area of the smaller square, and we are supposed to find the area of the larger square. Now, what we can find here is that this angle is equals to this angle. This angle is equals to this angle. This angle is equal to this angle. Because this is 90 degrees, and then this is 90 degrees, this is 90 degrees, this is 90 degrees. Just transfer some easy, just do some easy angle tracing. So now what we see is that this is 1, this is 2, this is root 5. Because all of them are similar, so that makes them all 1, 2, root 5 triangles. So now we want to make some connection between, call this y and call this x. They are side lenses. We want to find some connection between y and x. So what are some equations here? AB equals to BC. Can we do that? Yes, we know what BJ is, we know what JC is, we know what these is. We can find an equation between x and y. We'll start with BC. BC is BJ plus JC, and then BJ is gonna be x over root 5. JC is gonna be x root 5 over 2, according to 1, 5, root 2 triangles, 1, 2, root 5 triangles. And then if you add them together, you will find that BC equals to 7x root 5 over 10. Now, AB. AB, we have 3 segments here, so it's going to be a little harder. Now, AB. What does AB equal to? We separate them with BH, HN, and NA. They can all progress. They can all be calculated from x and y. What is BH? BH is gonna be 2 over root 5x. HN is root 5 over 2y, and then NA is 1 over root 5y. Now you add them, you get 7y root 5 over 10, my pen is barely working, plus 2x root 5 over 5. Now these two are equal. These two are equal. Let's just erase this. These two are equal. How can we calculate that? We scooch this over, and we get 3x root 5 divided by 10 equals to 7y root 5 divided by 10. So we get that 3x equals to 7y, and then what's y squared? What's x divided by y? X divided by just 3 divided by 3, 7 divided by 3. The area of KLM is 99, so the ratio of the area will be this. And then so y squared equals to 49. Y squared equals to 99. So just x squared is just this. Which get the answer is 539. Well, question 8, we have a positive integer n, and then let Sn denote the sum of the positive digits of n. Let's find the smallest positive integer satisfying Sn equals to Sn plus 864 equals to 20. Okay, so first of all, we know that n has to be at least 3 digits, because when n is like a 2-digit number, its mass can only be 99, which 9 plus 9 is smaller than 20. Then n cannot be a 4-digit number because it's out of range. So n has to be something like a, b, c. Well, n, we get 100a plus 110b plus c. First, we know that a plus b plus c equals to 20 because Sn is 20. And then if we add 864 to n, either, like, one of the 3 digits is going to be carried over, because when it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, the next one is 10, not like, I don't know. Then digit sum is 1, not 10, right? So we're gonna like case analysis. First of all, no digit exceeds 9 after adding the 864. Something like 133. We get 997. There's no carryovers. So it's gonna be case 1. We get, this is 20 plus 18. It's definitely gonna be more than 29. More than 20. Sorry. So case 2. A plus 8 is the only one that exceeds 9. So that means this is gonna be 9 something, and then plus, no. It's gonna be, the first digit is gonna be more than 1. So it's gonna be 2 something plus 864. We get 10 something, right? Because now 2 becomes 10. Something like that. Okay, so A64 plus n, we get it's 1, because the 1 at the top here, plus 8 plus A2 minus 10, because you carry over, and then the rest are the same. This is B, this is C, this is minus, and we get 29, which is not okay, right? Now, if there's only 1 digits that carry over, this is always going to be minus 10, and this is always going to add 1, so it doesn't work. Now we talk about 2 digits carry over. Case 3. A and B carry over. Which we get here is 20. Okay, now this looks possible, right? Well, what is gonna be like, what is gonna be possible? Give it a quick test and we can find the smallest possible one is 695. We leave that aside and we see if others can have more. Okay, so A and C carry over. From this, we know this is also possible. So we get the smallest number after a bit testing gets 999. This is more than 999 is more than 695. Case 5. All 3 digits exceeds 9. We get sorry, this is A, this is B, C. This is going to be less than 20, which is not possible. So we get the answer is 695 because it's the smallest one.